This conference will now be recorded.
So today we're going to start with our DevOps tools. And so before we start with the tools, okay, let's start with a small introduction about developers. Okay, fine. So we all know that developers do source code, right? They develop a code. Okay, fine. So for example, just take a small example. So we have a development team, and the development team is working on a project. Right? And in my team, we have about 4 or 5 developers, some number of developers we have in project. Okay. So if you have number of developers, let's say we have 5 developers. So these developers, they access the code or they share the code or not. For example, there's a developer 1, and developer 1 wants to have access to the code of developer 2, and vice versa. Right? So this is what we call source code sharing. Right? So code will be shared across the developers. Right? That's one thing. Okay. And moreover, let's say, so there might be some developers and they might delete some files by mistake. For example, let's say, so I'm a developer 1. I delete a file. Let's say I delete a file. It's my project file. Right? So this file was deleted about 10 days ago. Now, after some time, again, there are other developers and they were trying to access the same file. But can they access it? No, they cannot. Why? Because the file is deleted from your project itself. Since the file is deleted from the project, so the file cannot be accessed. Right? Now, what is the solution then? So, file has to be restored. Right? Clear? So these are the few things which developers require always. And moreover, so this also might be one more case. So there are 2 developers. We have developer 1 and then developer 2. And both developers are modifying the same file. Let's say they're modifying same file. They're working on the same file. They're writing some source code in the same file. If these both developers are working in the same file, or same project file, then the question is, which user changes are important? Is it developer 1 changes or developer 2 changes? Both. But I feel that developer 1 changes are important. You might feel that both changes are important. And developer 2 might think that his changes are important. Okay? So this is all, how we're going to resolve this kind of issue. This is what we call a conflict. So whose changes are important? Is it my changes, your changes, or both changes? Right. So if you want to have solutions for these all, let's say it's a conflict, we call it conflict actually. Conflict. So if you want to resolve a conflict, or else, let's say if you want to restore files, if you want to share the data, or else, see, my development team size is 5. Let's say we have 5 developers. Okay. Now, so my project source code can be accessed only by these 5 developers, not by anyone else. Clear? Then how it will be done? To be simple, can I say that I'm trying to manage my project security? So what is security means? So my project source code or my project can be accessed only by my development team, not by anyone else. So there might be some other team members. For example, let's say when you talk about a project, we talk about number of teams. So we talk about admins, we talk about deployment teams, we talk about middleware teams, and we have many teams. But since this is my project source code, this source code can be accessed only by these 5 developers. Why? Because of security reasons. But how do you provide securities? So, and the solution is, now here we talk about version control system tools. You can say that we talk about source code repositories. So these are the tools. We can call them VCS or version control system tools. or you can call them source code management tools, or you can call them shortcut SCM tools, SCM repositories. Right? So VCS tools are source code management repositories. These are the tools will provide solutions for all these questions. So how I can maintain my project security, how we can share the data, and moreover, so when you talk about how can we restore the files. So for all these also, questions, we have a solution which is source code repository tools. Okay. Now, but how we discuss these repositories? Anyway, we start with this repositories. But before we discuss the repositories, now do you understand the purpose of repositories now? Fine. Once we understand the purpose, then we'll start looking into what are the tools available in the market and what tools are mostly used, and so why we use those tools. Okay, fine. Let's move on to that topic now. Now, here we talk about tools. Now, there are various tools available in the market, and when you talk about these tools, and we have Subversion. So, in short form, you can call it SVN, and then we have Git, and also we have GitHub. Yeah, Subversion, and then SVN, nothing but Subversion, Git, and then GitHub. So SVN, Git, and GitHub, these are the version control system tools, and which are most popularly used. Okay, fine. But among these three tools, which tool is mostly preferred these days? Is it Subversion? Yes, it's GitHub, of course. Okay. So why you prefer GitHub? And the reason is again because GitHub is a cloud repository. I think we to be simply, if you go with a cloud repository like GitHub repositories, so we don't need any servers and then no maintenance. That is why we go for GitHub repository. I think that is clear, right? Fine. Now, so anyway, so we can divide the repositories actually into two types. One is so server-based repositories, and other one is cloud-based repositories. So server-based as well as cloud-based, right? And the examples are, this is for GitHub, is an example. And for server-based repositories, so there are many tools anyway. So these are the only, what are the tools you see, SVN, Git, and GitHub. These are just three tools. But apart from these three tools, are there any other tools available in the market? Yes, there are many tools for version controlling purpose. What are those tools? We have tools like Perforce. So also we have Bitbucket, and then we have TFS. So these are some of the other available tools in the market. But mostly these days, so like companies, they prefer GitHub or Git anyway. So, but again, why we prefer this GitHub or Git? So there is a reason actually. When you talk about architectural level differences, so Git or GitHub has many, these tools have many advantages. But what are those advantages? We'll talk about that later. When we go through the architectural level, we'll discuss that, discuss the differences. But basically, so we can divide the repositories into two types. One is server-based repositories, server-based, and other one is cloud-based. But these are the examples. And how about these repositories? Perforce, Bitbucket, TFS. So these tools also server-based repositories. Okay, I think to understand what is server-based repositories, right? So opposite to cloud. So what is cloud actually? Like no servers, no maintenance, of course. And opposite to that, what is opposite to it? Servers and then maintenance, of course. Anyway, fine. So for today, we're going to start with Subversion, which is SVN. Let's start with Subversion for today. And when you talk about Subversion, so first we'll start its architecture. How does subversion architecture works. We'll start with the architecture. And so what is the architecture we're going to discuss? That architecture is kind of a common architecture for all repository tools. Whether you take Git, GitHub, DFS, Perforce, all these tools work with kind of a common architecture. That kind of architecture we're going to concentrate now. So what is that architecture and how does it work? So we'll just look into it. Okay. Now, so this architecture we're going to discuss now will help us a lot in understanding any other repository tools. So please concentrate. And moreover, this is a very easy architecture. Okay. So it's nothing complex here. It's all about like, so see, in Subversion, it's all about command based. We have commands all. So not only Subversion, any version control tools we have commands. It's all command based tools. These tools are. But so the problem here is we might feel complex if you don't understand the architecture, because in these tools we have many commands. We should, if you understand that architecture thoroughly, then you will be able to understand where we use those commands. Right? So architecture, understanding architecture is very important. If you understand that architecture, then you will know, okay, what command I should run next. That is important. Okay, so that is what we're going to concentrate. And again, I repeat, this architecture so is like very much similar to any other repository tools, Git, GitHub, or Bitbucket, whatever it is. Okay, but so let's concentrate on that architecture now. So moving on to it. So let's start with first. Okay. Let's say in my project we have some developers. Let's say we have 4 developers. Let's say, assume that. So here we have developers. So developer 2, and then developer 3, and then we have developer 4. Fine. So we have 4 developers, and then so what developers do? Developers design the project source code. Okay, fine. Let's assume that I'm a developer 1. Now, if I'm a developer 1, so I'm writing some project source files, and where I'm going to design or where I'm going to write my project source files. So what I mean is, let's say I'm a developer 1, that is my system. Okay. Now, let's start writing my project source code. Okay. Now the question is, where I'm going to write my project source files. So can I create my project files in anywhere, in any path? So no, you cannot. There is a path restriction. There is a standard path. So make sure as a developer, you create your project files only in that particular path. Clear? But what is that path? Now, here we talk about working copy, or you can call it local repository. A working copy or a local repository. So what is a working copy or a repository? Okay, so the name itself says, what is that? It's a local repository. What is a local repository? Local repository in the sense, every developer, they maintain their own kind of project itself. All the files will be created. That is what we call your local repository. Okay, fine. Let's take an example. For example, let's say that is my project. Okay, now, so this is what I'm going to consider as my local repository. In this local repository, our working copy, I'm going to create all my project files. Is what we call your project repository, sorry, local repository, our working copy. Now, so how many developers we have? 4 developers. Now, every developer maintain their local repository, working copy or not? Okay, fine. So let's talk about the working copy. So these are all local repositories, our working copies. Okay, now we are working copies created, but the question is, so how do you create this kind of working copies? Is it something like I create a new folder, something like this? No, not exactly. See, this looks like a folder for us, but it is not exactly a folder. That's why I call it as local repository or working copy. How do you create a working copy or local repository? Fine. Now let's talk about that. Now, if you understand the purpose of working copy, local repository, a repository, or you can say folder, where developers work on their project. So if you have 5 developers, yes, every developer maintain their local working copies. Once the source code is being designed by all these developers, then the code will be saved onto the server repository. There is my server. That's my server. And on that server, let's create a repository. This is my server repository. Let's give some name. Let's say repository 1, repo 1. Okay. Now, so now look at here. Let me just give you this idea. So if you are all developers, so what do? Source code design. Once code is designed, and then the code will be saved onto the server repository. Is it correct? Now, can I call this repository as centralized repository? Yes. Why centralized? Because your code from all the developers is saved onto the repository. That is the concept of repository concept. Yeah.
Every developer is a single repository.
Yes, for every developer, so there will be a local working copy or a repository. But how do you get the working copy? We'll see. Okay, so all developers maintain their own local working copies, and since these developers maintain the code locally, the code from the local copies will be saved onto the server repository. Why the code is being saved on server repository? To manage? Yes, as centralized. So what is centralized? Available at common location? Yes, that is what we call centralized. Okay. Now, then, so let's talk about this working copy again. How we get these working copies? So how to create these working copies? Working copy is nothing but a folder, but we create kind of a new folder. Do we create a folder? No, not exactly. How do you get that working copy? Now, we get the working copies. So by following a procedure we call it checkout. So we call it SVN checkout. Now, for example, I'm a developer 1. As a developer 1, I started working on my project. So since I started working on my project, I should get a working copy or not? Local copy. What is a local copy? Local copy is nothing but copy of your server and then on local. That's it. That's why we call it a copy, or we call it a replica. So copy of your server, repository server maintaining locally is what we call server repository or local repository. But how do I get that working copy? By using a command called SVN checkout. For example, I'm a developer. As a developer, I just open my command prompt. Once I open my command prompt, then I run a command called SVN checkout. So after I run this command, then I will be able to see my working copy, or you can say repository. There is my repository. That is how you get it. It looks like a folder, but how to create this folder? How to get a copy of it? By using a command called SVN checkout command. Okay. Then after I did a SVN checkout, then I can see that working copy. Okay. Fine. So this checkout has to be done by all the developers or not? Yes, because all the developers are working on same project, isn't it? Yes. So let's do a checkout. So there we have all the developers ready to checkout. Yes, now checkout is done. So once checkout is done, then we have your working copies created. Okay, fine. So we're done with the first step. Checkout is done. And let's move on to the second step. Now, as a developer, now I just proceed with open my repository. I got a working copy. I open my repository, and then I start creating some files here. Let's say, one second. So I'm creating my project files. Okay, and I open that file and I write some source code in here. Fine. And save that file, save it. Okay. Now tell me what is next. I'm done with my source code. So let's say as a developer one, I'll just say the file is created by me. So what do you do next? Yes, correct. Right. So whatever the changes are done by the developers, make sure all these changes must be saved onto the repository, centralized repository. So any change you do on your project, make sure that is being saved on your repository. So why is it so? Why we should save our changes as a developer? Why we should save our changes to the repositories? But is there any reason why developers saving make it centralized? Sorry? Okay, for sharing purpose, yes. So this code can be shared by other developers, can be shared to other developers. Okay, fine. Any other reasons? Okay, security one reason. Okay, fine, that's correct. But like the reasons, whatever we discussed. Fine. So whenever your source code is being saved on your server repository, then your code will be more secure and moreover sharing purpose. And other reason is so you can do version control on it. That means even the file has been deleted, the file can be again restored. Okay, fine. Anyway, so that's the reason. Always make sure any change is done by the developers, and the changes must be saved onto the repository. Okay. Okay. So how do you do that then? Then here, what is the command again? The command is SVN commit. SVN commit. Fine. And once it's been committed, then you have your file is available on your server. Okay. Now the file is available. But the question is, so whenever any file is being saved onto the repository, the file will be saved in terms of encrypted formats. So what does encrypted means? For example, I'm administrator. Okay, let's say I'm admin. So I'm admin. So being an admin, can I access to this? Can I log into server or not? Yes, I can log into server because I'm administrator of this server. So that means can I access this, can I open this repository folder on server? See here I'm talking about on server. Okay. Now if I open that folder on server, so will I be able to see all the files of your repository? Okay. But I won't be able to do it. So whenever you open your server and server side repository, server won't display all the files. Why? Because the files are in encrypted formats. So even though you are admin, you are developer, if you log into server, open that repository, now you won't be able to see those files because the files will be saved in encrypted formats for security reasons. Okay, am I clear? Fine. But what is that format? That is what we call revisions. So what we call it? Revisions. So whenever any developer so do changes to the project, and then once it's been committed, SVN check, SVN commit, then the files will be committed in terms of revisions. Revision. So revisions will be maintained in terms of numerics. Revision 1, revision 2, revision 3, so on. Now developer 1 has committed his changes, and his changes are saved in terms of revisions. What's the revision number? Revision 2. But why not revision 1? So revision 1 means it's a new repository. Okay. Then as soon as developers started committing the changes will be saved in terms of revision. Now, did developer 1 Did they commit or not? Yes, they did a commit. Then all developer 1 changes are committed in terms of which revision? Revision 2, not revision 1. Revision 1, nothing but it's a new repository. Now, as soon as any developer commit the changes to the server repository, the revisions will be incremented. For example, I'm a developer 2. I'm doing a commit onto the server. The revision will be increment, revision 3, and the revision 4, revision 5, so on. So revisions will be incremented. Remember this. Okay. Now, so developer 2 changes are saved into the revision 2. Am I clear? Fine. So this file has been saved as encrypted format in revision 2. Yes, that's been saved. Okay. Fine. Now, so what is the current revision number of your server repository? Revision 2. So repository maintains revisions as I said. Okay. The current revision number of your repositories on server is revision 2. Okay, fine. Now again back to this checkouts. Developers already did a checkout or not? They already did a checkout. So that's the reason they have their working copies created. Okay. Now while the checkout was done, sorry. While the number they did a checkout too. Revision 1. Is it correct? Why? Because developers did a checkout initially, right? So before developer 1 committed, then before that it was done a checkout. At the time when checkout was done, revision number was revision number was 1. Sorry. So remember this. Whenever you do a checkout, so checkout creates a local working copy. Am I correct or not? So what is a working copy means? It is a copy of your server. Now, at the number, repository revision 1. That's the reason all these developers also their local repository revision is revision 1. Am I clear now? Fine. So what is the revision they are working with? They are working with revision 1 locally. So revision 1. Okay. Okay. Then can I say that this developer 2, 3, and 4, their repository is out of date, their local repository is out of date? What is out of date? Or can I say that their repository is not up to date? Now, what is that not up to date? Yeah, correct. So these 3 developers, they are not up to date. What do you mean by not up to date? So to be simple, your local repositories must be maintaining same revisions as your server. But for these developers, are they maintaining the same revision as your server repository? No, they are not. That means, can you say that I'm out of date when these developers out of date are not up to date? Yes, that is what you mean by up to date. Now, according to any repository concept, any version control system tools concept, your repositories always must be up to date. So, what if I'm not up to date? Then what is the question? So, if I'm not up to date, then you will get many issues. For example, you are developer 1, I'm developer 2, right? You're working, you already done some changes to your files and which has been saved on server. Now, as a developer 2, how do I see those changes? Am I clear? So since my repository is out of date, I'm not able to see it. Then tell me what is the solution then? I want to see all the changes which are done by you also. How do I see it? What do I do now? See, what is the solution? What is the problem is not up to date. Now, what is the solution? Up to date, right? So once I update as a developer 2, so once I update my repository, I will be able to see all the changes, whatever is available on this server repository. So will I be able to see all the changes or not? Why? Because developer 1 did commit his changes to what revision? Revision 2. So as a developer 2, if I want to see the changes, then I should be, as a developer 2, I should have that repository revision 2 changes in my level developer 2 local repository. Now the question is, how do I update it? Now here we talk about update. Now, so how to update it? The command is SVN update. Now let's say I'm a developer 2. As a developer 2, I just go with SVN up or update, both are same. So once I update it, then I can see revision 2. Yes. Now it is revision 2. Okay. Now in revision 2, so there was a file, right? What was that file? Hello.java file. Yes, I have that file. Okay. So that is what we call update. Simply, in simple terms, if you want to understand what is update, it is nothing but synchronizing. Synchronizing our local repositories, same as server repository. That is what we call update, nothing else. Okay. Now let's say as a developer 2 now, I'm just writing some source code class something. Okay. Now this source code is being added by developer 2. Okay, fine. The changes from developer 2 are done. So what is next? Again, commit it or not? So this is what is said. So every change, so what are the changes is done? Whether you remove a file, you add a file, you modify a file, whether you rename it, any change has to be saved on your server. This is what we call committing it. Okay, fine. Let's commit it. Done. So go with commit. Now, once it's been committed, there will be some changes recorded on your server. What is that change? Yes. So when the revisions will be created, revisions will be created on every successful commit. So now developer 2 did a commit. Now what's the revision number is? Revision is 3. Yes, revision is changed in revision 3. Now developer 2 has done his changes, committed his changes. Okay. But again developer 3. Now tell me what he has to do first. Always update. Fine, let's update it. So if you don't update it, there will be many conflicts, many issues. We'll talk about that later in the future. Now let's update it. Okay, once it's been updated, now developer 3 revision will be revision 3. It's up to date. Local repository is up to date. Then so I can see that file, and then so also changes, modifications, and let's say he's adding his changes now. Fine. And then what's next? Commit it. Yes, as usual, commit it. Yes. So I'm committing also as developer 3. Let's revision will be 4. Revision 4. Right. Now let's talk about developer 4 now. Now what he has to do again? Update. Okay, always make sure you update it. So if you update it, everything will be like a failure. So let's update it. But this time, developer 4 is trying something else. Revision 4, and he is going to remove that file. Remove file. Now, so other developers, they keep modifying that file, but this developer 4, he wanted to remove that file. Okay, file has been removed, and once it's been removed, again same thing, commit it. Okay, let's commit it. And so once committed, and revision will be 5 now. Okay, so revision is 5. Revision 5. Now in revision 5, the file is deleted or not? Okay. So the file is deleted, let's say today around 9th March. But after some days, now there comes the issue. Developer 1, we have developer 1, and he wanted to access the same file. He wants to access the same file. Can you access that file? Okay. Before that, let me ask you one more question. Now, currently, what is developer 2 division number? Division 1 or division 2? Division 2. Okay, fine. So, for the time being, understand revision 2, but technically that is revision 1. Why revision 1 technically? So I'll explain that part later, not now. So when we move on to practical things, you'll understand it. Okay, fine. But practically or technically, so this is revision 1 still. Why that is so? I'll explain that later. Fine. And this revision is revision 1 still. Now what is going to do first? Or else, see, so he assumes that even his team members are doing some modifications on the repository, and since other team members are also doing some modifications on the repository, he has to update his local repository or not. Always make sure. So this is a blind rule. Any developer always must work with local repository up to date. Okay, he's updating it. So let's say he's updating. Once it's updated, and revision will be division 5. Okay, so here we have division 5. Fine. And then what? Can I see that hello.java file? No? Why? It's deleted? Yeah. So you see that in revision 5, is the file is deleted or not? Yes. The file is deleted. So that's why I'm not able to see that file. But how I can get that file? Sorry? Yes. So since we have, see, the reason why we are making these revisions are because if we can go back to those revisions, we can see those files again back. So in revision 5, file was deleted. That's correct. But in revision 4, the file is maintained or not? That the file was available in revision 4. So we can get that file back again from revision 4. Or we can get that file from any revisions starting from revision 2 till revision 4. Why? Because in revision 2, file was created, revision 3, revision 4, the file was available in between these revisions. But I want to restore the file only from revision 4. Why? Because in revision 4, the file was updated revision. So revision 5 file was deleted. Before that, what was updated revision? Revision 4. So I want to restore that file from revision 4. Okay. So as a developer 2 now, developer 1, instead of updating to revision 5, if I update to revision 4, can I get that file back again or not? Yes. Yes. That means, do we have control of those revisions? So what do you mean by controlling it? So switching back and forth. We can change your revisions anytime and any revisions. Is it clear? So that is what we call version control. We have the control of the versions or revisions, you can say. Right? By moving on to those older revisions or older versions, we can put those files again back, restore. So this is what we call version control. But how to do version control? Now, doing a version control is, of course, looks easy, but while we do version control, we need to take many things into consideration. So we'll discuss all those. So what are the issues or what are the scenarios comes into picture while we do version control? So the reason is, say, you are trying to restore the file, but there might be some other developers, they are also doing the same things or not, right? Then how to resolve it, right? So we will discuss them all these things clearly, practically, on scenario basis. So we'll look into that from tomorrow evening. Okay. So now do you understand this how the life cycle works. It's a very easy life cycle. And when you start with Git or GitHub, so these repositories also so follow same kind of life cycle, but with some minor differences. So SVN also has commit command, update command, checkout command. Same as Git also has the same commands, but there are some differences. Okay. And so this kind of architecture, what do we call it? So we call it a basic client-server architecture. So SVN follows a client-server architecture. So this is what is SVN architecture is. So remember, this is a very important point. So and whereas Git follows a kind of a different kind of architecture, and in most of the interviews can expect this question. Can you explain? You have been working on SVN, also you have been working on Git or GitHub. But the differences between these tools, SVN architecture and Git architecture, what are the differences? What is the architecture they follow? At architecture level, what are the differences you find? And how to differentiate them? So that is an important question. So if you have any questions on repositories, that's 90% of the chances that you may get asked this question. So the architecture level differences. Okay, but so anyway, let's start with this SVN now. So now look at the steps, life cycle steps. You can say life cycle or architecture, whatever you call it. Now, what are those steps? Step one is SVN checkout, and step two is, let's say, do modifications. So once you have the repository, local repository ready, so as soon as you do checkout, what will be created? The working copy. Okay, fine. And then we do modifications. So within working copy, we do modifications. That means we create files, or else we just modify them, we rename them, and then we delete them. Fine. Okay, next. Commit it. Yes, commit it. So okay, fine. So that's very basic. Then how about update? So when do you do update? So in this life cycle, tell me where that update command comes into the picture. Revision is not up to date. Okay, fine. Okay, always let me ask question in another way. Difference between checkout versus update. What checkout does, what update does. Yeah. So checkout is for, see, let's say I'm a new developer. So I'm a new developer joining your project. So as soon as I join the project, what do I do first? I do checkout? Yes. So when I join a project, I do checkout first. So once I do a checkout, then, so will I be doing the checkout every day? No. I will be doing only first time. So second time onwards, I'll just concentrate only on update. So that is the difference between checkout versus update. Okay. So checkout is done once to get the copy, and update is done every time as you do. So working your project. Okay. Checking is nothing but committing.
Yeah, so we have to commit the now.
Okay. If you commit it and then update it, okay, you can do it. But what without committing, can I update it?
Yes.
There will be conflicts. Okay, of course. So that might happen. Of course, that might happen because if I'm a developer, without committing my changes, can I update it? By mistake, I might have done it. That is, there are very good chances, of course. If that is the case, what is going to happen? I might lose some changes. Okay, we'll discuss these scenarios in practical decisions. Okay, so of course that might happen. So if you do it, then Am I going to lose my data, which I have done my changes? Am I going to lose it? Yes, definitely you will lose it, but you don't. So there are some steps we need to follow it. Okay. We'll just talk about that. So back to your architecture. So let's say as a developer 2 now. So what is my current revision number is? Let's say revision 2. But on server, what's the revision number? How do I know that? So how developers know that the current revision number on your repository, on server-side repository, it's revision 5. How do I know that? Sorry? Using the command. So instead of using a command, okay, fine. Let me just ask you this question in another way. For example, I'm not a developer. Okay. Now I might be your manager. I might be from client team. I want to just check your source code of your repository, or I want to see all the files available on your repository. How many files have been designed, and what are the folders you have? What is the source code you are maintaining, and how you are following that architecture? I want to see your project, entire project source code. So in that case, do I need to do a checkout? See, first of all, I don't even know that what is the SVN checkout command. I'm not from a technical team. If you are not, I'm not from a development team, then how do I know that I need to do a checkout? Here, but simply I just want to look at your source code on your repository. So how do I do that? Accessing the repository, okay, fine. How? Mm-hmm. Okay, fine. You might be correct. That's correct. You're almost there. Now let's talk about here. Now, for example, let's say I just open my browser. Okay, let's say that's my browser. Now in my browser, I just entered my server IP address. This is your server, right? Okay. Let's say my server IP address is that's my server IP address. Let's enter that server IP address here. Some HTTP and then 136. That's my server IP address. Okay. So why I'm trying to access my server? So I don't want to access that server. I want to access repository on the server. Okay. So how do I do that? Anyway, with the help of server IP address. Fine. We have server IP address. Next, what else I enter in my browser? So you want to access that repository on the server. Okay. Then in the browser you enter your URL, right? Okay, that's my browser. So what I have entered IP address first. Okay. So IP address. Then what? Okay, I enter something here. Port number. Don't worry about that port number. Okay. Slash. On that server, what is that? Repository path. In which path your repository is being configured? What is that folder name? See, first of all, we have set up this repository, right? So once you have the repository set up, once your repository configured, then only you have the repository available. But in which repository or what is that folder, what is the directory name or path of the repository where this has been set up? Okay, clear? Now what is the path? Now talk about that path. The path is, let's say, somewhere in root repository 1. So that's my path. So in slash is nothing but some directory, root directory, and there you have entered. Now the same thing I have entered on the port path. Let's say I'll just enter here. What is that? Port number. We'll discuss that port number anyway. Some port number and slash your repository path. What is the repository path? Slash repo 1. There I have my repository created. That's my folder name. Okay. There. So once you enter here, then on your browser, you will be able to see all your repository files. Files available on your all the list of files on your browser. So let's say that's my URL. Once I enter that URL, and here I will be able to see all the files of my browser, of my repository. Desktop files. But this is your browser, right? Okay. Since it's your browser, is it for read-only purpose or not? So the files are only read-only mode. You cannot modify those files. So it's only for view purpose, read-only purpose, not for modifying. There is no write access here. It's you have only read access. And also you see on top of here. So what's the revision number? What is the revision number you have? You'll be able to see that revision number 5. In revision file, you can see all the stock files. Okay, fine. And later I just go with, now let's say as a developer 2. So what's my revision number? Locally 2. And on server, what's the revision number is 5. Yes, now I can compare it. I can compare that on revision, it's revision 5, server, it's revision 5, locally, it's revision 1. I can compare it, right? There I will be able to see. And then once I compare these files, what would I go with next? Update it? Yes, let's update. Okay. So this is how you compare your repositories and then with that top browser. But let's talk about some more details in it. Let's talk about something like that port number. So what is that port number? Port number 18. Why that port number 18? Now, when you talk about port number 18, you see that, look at my browser again. In my browser, what is the first part of it? IP address. Okay, fine. And whenever you enter that IP address in your browser, you will be pointing to your server. Okay, fine. And then we have 80 port number. What is that 80 port number? 80 port number is nothing but your web server port number. So, and here let's talk about a web server, and we talk about a web server which is Apache. Now, let's say Apache web server. It's a web server. So why I have this web server? What is the purpose of Apache web server? Now, the purpose of Apache web server is, see, look at here. You're loading your repository through browser or not? Is it my browser? Fine. So you're trying to load your files through your repository, which is your web browser, of course. Now, if you want to access any file through your web browser, then your browser must able to point that file or not, or else your browser has to list those files on your browser. But how that will happen then? If your repository is configured with your web server, and then your browser will be able to load all these files through the Apache web server. Okay. Or simply, so what happening here is you're pointing to first server, and then next 80 port number. 80 port number belongs to Apache, and from there repository part. There we have repository part. Since my repository and Apache server have been integrated or have been configured together, so that's why I'm able to load these files to my web browser. If your Apache and then your server, Apache and then your repository, SVN repository is not, they are not integrated, then you won't be able to load your repository files through Apache or via browser. Say, for example, we all access Gmail, right? So how are you able to access Gmail? So because your Gmail application is deployed on a web server. Now, the same logic here also. My repository is deployed or configured on an Apache web server. So that is the reason I'm able to access those files from my browser. Simple. There's nothing too much complex about this. That's it. So there is some web server running. On that web server, we have a repository. Yes, you can access that through web browser. That is what is your, so why we need our web server, which is Apache. Now here I'm going to use Apache web server, and Apache will be running on port number which is 80. That's Apache port number.
What if we use another website?
So you can use any web server. For example, let's say I want to use Tomcat web server. You can use Tomcat web server. In that case, port number will be 88. Port number changes. Okay. So now in this case, we must also have Apache server installed or not. So we need Apache web server. Is it correct or not? Yes, of course. Otherwise, you won't be able to locate all these files through your browser. That's not possible. Okay. Now that is what we're going to install. So when you talk about installation, so we install, of course, Subversion. I mean SVN, of course. And what else we install? Apache. Okay. Now, when you install Apache, Subversion means, is it nothing but we are installing Subversion software or not? Of course. And plus, what else we are doing? While we install it, we also go into create a repository. So you are storing the data. Where you will be storing your data on? Server, repository? Yes. But if you have that SVN installed, then only you can have that repository. Anyway. So while we install Subversion, we'll be having our SVN installed, and as well as same time we can have your repository created. There it is. Okay. And then we install Apache web server. Yes. Fine. So these are things what we're going to install. But instead of installing these two separately, see, let's say I'm installing Subversion first, and later I'm installing Apache. So we're installing, okay, fine. But once they're installed, we must do something else. What is that? We must also integrate them or not? Yes. Once they're integrated, then they'll be able to load it. Okay. But instead of installing them separately, so we can have one single installation. That means with the help of that single installation, we can have Subversion installed and same time Apache installed, and plus they come integrated. Suppose when I say Subversion means it's a repository, of course. So Subversion will be installed, and as well as Apache will be installed. And moreover, they come integrated. We don't need to do any kind of configuration settings separately by integrating these two. Okay. So how do we install that? So if you go with that kind of installation, so we can prefer Bitnami Subversion. What is that? Bitnami Subversion. So Bitnami Subversion is nothing but Subversion installation, same time Apache installation, nothing else. So it is integrated installation. That makes our job easy and to install it. So you can install it, and you don't need to have any kind of separate installations. Okay. But how are you going to install this Bitnami Subversion? So now, if you can download it, you can download it for today, but we'll be installing tomorrow. So Bitnami is just an organization, just a company. So what do? They provide these kind of files. Yes, you can download these files. We have integrated. You can download it and then install it. Okay. Now Bitnami. Just that's a URL. Enter that URL. So Bitnami has many things already integrated anyway. They have many products That is the beauty of Bitnami anyway. So let's try with this applications. And there we have, so all these, there are many actually, there are too many, right? So that's a very good business anyway. But let's say, what is that? Subversion. Subversion. Click on it, and then so go with, let's say virtual machines, and then what is your OS? According to your OS, you can download it. I'm sorry, not virtual OS. Windows, sorry. Windows, Mac, Linux, and download for Linux. Download the Linux version. Okay, just get it downloaded, and we'll be installing it tomorrow. So get it downloaded, then we'll install that tomorrow. How to install it, I'll show you that tomorrow session. Okay. So let's wind up it 10 minutes earlier today. So because I can't speak out anymore. So I got some very severe infection. That's okay. But so let's get it downloaded today, and then tomorrow we'll start with installation. Okay. Any questions? Any things which are not clear regarding this architecture, or anything regarding this Apache or whatever? So it's easy, very easy concept. So just go through it again. Once you go through it, things will be much easier to understand. Okay. Yeah.
The email notification can be integrated with the users.
Yeah, of course, you can do it. You can set up email notifications also. So you can set up many things, of course. So if you want to set up some email notifications, can be done. Or you want to set up some triggers. So there are many things, of course. Okay, you can do it.
So when we open any line within like we see the line numbers. We have to any command or we also to jump to any line.
Yeah, there are more than many commands. There are some commands. So just can't remember exactly those commands. Yes, we have those commands. If you want to jump to any line numbers when you open that VI editor in Linux, yes, you can do it. If you want to jump to the last line, first line, some line number, we have commands. So you can refer the documents. I have uploaded a document, right? On next folder, you can refer the document. But, yeah. Any more questions? Thank you. I'll see you tomorrow.